Microservices. Uh, Nowadays, there is a new terminology called cloud native applications, right? So, and there are too many languages also, right? And there are some good languages like Node.js to handle intensive IO operation that can handle better than other language. So each language, when it comes out, it has its own flavor of the advantage over the rest, right? But one of the beauty about the Java is the language comes and goes, but Java is there for last 20 plus years, and it keeps evolving, right? And JDK itself is evolving every releases, right? But if it is only a Java and JDK, then yeah, there is only so much you could do. But Spring has come out. Spring framework has removed all the mundane jobs, cross-cutting things, and they made it more simplified framework. But now, as the Java is evolving, Spring is also evolving, and there is going to be a Spring Boot, which is making the Java much easier. So we are going to talk about that also. Okay. What is the pros of the microservices? Is basically separates the requirements and enables cross-functional teams to build each part of the stack using a preferred technology. So this is the key, right? For example, if you really need a IO intensive application, you might go with a Node.js. And even if you don't have an expertise, if you need such a performance, probably you might have to invest. And now you have an opportunity to identify a team or groom a person to do that. So that that particular component alone will be developed in Node.js. The rest of it, if you are a Java shop, you could develop using the Java itself. Um, so now the technology enables, the microservices technology enables us to do that. With separate microservice making up each part of the application, scaling now becomes much easier and efficient. So previously each application we have to take care of the scaling as well, right? As the developer option. Now the framework using the Dockerized the deployment options for the microservices takes care of those scalability issues. Okay, so pros, we know that now you could have compartmentalize your project into multiple functional project, and each project you could choose the right technology, right languages. Unlike before it was a Java sharp, C sharp. That means all the components will be developed with that particular thing. Now you're because people only knows that because it was a developer has to take care of the scalability. Now the frameworks, microservices and Docker and the orchestration of those Dockers takes care of minimizing all those mundane lifecycle scalable issues, irrespective of the language. That's the key, right? So now it gives a boost for the whole architects as well as developers to think differently and come out with something called cloud native application, right? So now we are talking what is cloud native application? Compartmentalizing your components as a microservices, see what kind of issue you are solving through that microservice, choose the right language, and try to develop and deploy it as a Docker container. That's it. Then each microservice can talk to each other irrespective of the technology, and all the lifecycle events and auto scaling, everything takes care of by the container like Docker containers. So these are all the new things. What are the cons of this approach? Incredibly difficult to refactor the existing traditional application to be truly microservices cloud native. All these are quite new, and people are thinking, what is the boundary between a monolith? How to cut a monolith into a different slices of microservice? That's an art rather than this is one kind of an approach. So that comes out with experience. So we are going to take one example. So we have talked more on the microservice. This is a use case what we are trying to talk today. Movie catalog. Okay. So a catalog, if you see the bottom figure, right? A movie catalog service which takes the input as the user ID and it's going to return you the movie list with the corresponding rating. Okay. So this is your requirement. But how to realize this requirement? Usually, the movie info will be talking to its respective. There are some REST APIs available where if you pass the right information, it gives you for a particular movie ID all the movie details. Okay, so you don't have to own it. So that belongs to a separate job, and it caters to its own microservice. Similarly, given a user ID, movie ID, and the corresponding ratings, that will also be managed by separate provide people, right? And this catalog service is basically trying to compose both from the movie service as well as from the movie rating data service. I took this use case because this gives you an idea like uh, uh, to come out with a monolith to microservice is one way of looking at it. This is an approach where if you have an existing service, for example, a movie info service, it's already existing service, and a movie rating service also a existing service. Now the movie catalog is like a composite service which calls and try to get both the information together. So this is one way of looking. Eventually, I think more and more microservices are going to be composed to make a usable business services. This is one of the examples for it, and this also gives you an idea. If you have a monolith of a catalog, movie catalog service, okay, it's better to keep it segregate the functionality separately so that the rating could be managed on its own, so that that complexity should not be come to the catalog side of it, right? And one of the reason is the scalability wise, the rating might be having a different scaling requirements as compared to a movie info service, right? And previously in monolith, if you do everything as a one catalog service, you can only maintain only one scalability yardstick for the whole application. Now what this gives you based on the need, you could scale the individual services to cater the catalog, and there could be other services which could be consuming the movie info and rating as well, and so that way your composite services are going to be more business like to compose the functional microservices. Okay. Got it. So far, we talked about functional wise microservice and why. Now we are talking about the technologies going to be used for this project. Spring Boot to develop microservice. What is a Spring Boot? Okay, so Java most people know, and Spring also most people know. Spring Boot has come on top of it. What it is? It is an opinionated view of the Spring platform, which pave the way for a faster and more efficient development ecosystem by assuming default starters by bootstrapping through. So it's all blah 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 words, but basically what it is doing is it gives you the Spring Boot by assuming the defaults. Okay, if you developed a Spring application, so many XML things to be configured, or so many annotations to be configured, just to make things easy and deploy, right? But at the cloud native era, what's happening is things has to be faster. It should be developed yesterday, right? So that is why this framework has given you those things by bootstrapping through default configuration. It's basically sorts a Spring application context, right? And performs the class path scan. It's using a Maven, so it's using a class path scan. Start an embedded server, and see, once you have one Java application, if you right click the Java application and run, if you see the application running without much on effort, Wow, right? So that is what this is going to give you. By default, these are all the four things, correct? And there are hundreds, I think even it's growing a lot, starters, right? For every popular things like JDBC, JPA, Apache Camel, Cloud Native, they all have the starter things. So all you have to do it is while you have to go and create your Spring Boot application using the start.spring.io, which is nothing but it gives you a Eclipse project. It gives you a project that you could import it in Eclipse or NetBeans or some anything. So we are going to use an Eclipse to open the project and see what it is. Okay, what else? How it works magically, right? The magic. We will. I want to show you a demo right now, and then come back and talk about the magic piece of it. Okay, so that makes it a little bit more easier. Okay. Like I said, we have three microservices. Those three are like movie rating, movie info, movie catalog. Okay. So how do we do that? Let me close the rest of it. Okay. So now we are having so you will have an application which has the main method, and all you are trying to do is Java application, run as a Java application. Okay. So when you say run as a Java application, what it is happening is it's if you see the log file, it is trying to do a Tomcat context. So it is trying to create a context loader, and it is deployed into a embedded Tomcat. Okay. And so let's see, instead of talking, let's see if he has something to test immediately. So probably we can say localhost, this one, rating.data. Wow. So the code has come, and I'll show you the code behind. It is, so now what you're seeing is given a user ID 100, it's going to give you the corresponding rating. It's saying movie ID is 100 and rating 3, and this guy has seen the movie and the movie ID 200, which are the rating 4. And there is another container metadata service, which we'll talk about it later. Okay, so let's see how this works. So now we saw that we just ran a Java application, right? So what are all the things you have to do to create is first you do something called a controller class. Okay, and this REST controller annotation makes any class into a controller of the REST API, right? And that means you could use the HTTP protocol and communicate. Communicate with what? So whatever the request mapping here, right? User dot user ID. So if you see here, we use user slash 100. That user slash 100 comes basically based on this thing, right? User ID. And so it is basically trying to call the init data. See, there is something called the user rating dot init data. User rating is nothing but a POJO thing. So if we go inside, so user rating is nothing but it has a user ID as a string and a list of rating as a ratings. That's it, right? And it is calling init data. And in the init data, we just simplified the whole microservice. We are just hard coding it. We just say 100 equal to 3 for the movie number 100. Rating is 3. For movie number 200, rating is 4. That is why if you see here, 100 rating is 3, moving 200 rating is 4. It basically comes from this. So all we have to do it is just to create these three things. One is Spring application dot run with the main method. It's an application, right? This is what you are running, and it is trying to run it in a embedded Tomcat server, right? And what it does, it is basically trying to talk to the REST controller, right? Since we are using the HTTP way, and based on the request mapping, it is trying to invoke and whatever the logic you mentioned here, in this case the logic is very simple. I kept it very simple, just to iterate the point. We don't have to do anything else to dispatch the servlet, how to show it in the UI, what is the web.xml, nothing. There is not everything is gone with this magic bullet, right? Now let's go back to the thing. Okay, so far we talked about what is Spring Boot, right? Now it uses auto wiring the services using annotations and no web.xml. At REST controller enables the class to REST controlled, and request mapping maps the URL for the REST API. So that is what we exactly saw now, right? So far so good. And I will show one more thing. If you guys see it here, this is a perfect Maven project, and you have the pom.xml file. And if you see the pom.xml file, this is where the magic things are there. See, it is a opinionated framework, right? So when I say opinionated framework, where all the so is using starter web, right? The Spring has so many starter projects going forward. So if you start including it, it does take care of how to dispatch the servlet based on your annotations. As long as you keep the annotations properly, you don't have to do anything. Same thing with the data.jpa. So that means it knows, oh, okay, I have to talk to database, so I know what to do. Same thing, Spring Cloud Starter. So it knows how to talk to Spring Cloud specific things, right? The lots of com dot it is using every, since you are using a JPA, it is actually saying, okay, it needs to have a tom. You're not doing anything. We didn't do any single code for this. It automatically the H2 database for you. Okay. Um, so based on the starter project, it adds all the dependency, right? It has the goldfish, and okay, so soon I'm going to talk to you about the Docker and so on, how to do it. So there is a Docker code also here, but right now I just want to keep it simple to make you guys understood uh, how these things works, right? Um, So, like I said, you could go and modify the pom.xml the way you want. For example, default it puts the H2 database. If you want to put Oracle, all you have to do is just go and configure the Oracle within the pom.xml the old way, right? We don't have, it's not stopping you anything, just jump starting you with whatever you need, and then you can do on top whatever you did before. Okay, so this is one thing, and similarly, I want to show you the other two projects. um, the rating is one, the another is the info, right? So what are the three? Usually it has the three classes, right? One is the application class. So let's go into the movie thing. All you have to do it is right click, run as Java application, correct? So it is trying to run the whole application within the embedded Tomcat. Okay. So let's go and go to the URL. I think it is localhost 8082 movies.200. Okay, see, blah blah blah. Wow, so it gives you movie ID 200 name, Star Trek injection in description, and a huge thing of descriptions, right? Let's see how this is. So previously, I showed you the rating. Rating was very simple. It is having the movie ID and the rating, which is kind of hard coded. You could do anything you want. I want to show you the simplest. Now I want to show you something little complex. Okay, the implementation side of it. Okay, so as usual, if you go here, you have to go to the controller class, right? The controller class will be having the annotation REST controller, right? And it will have the corresponding request mapping, right? But you see the implementation now. It is trying to call the REST API. What is REST API? REST API is nothing but REST template. So So this is one more thing I want you guys to understand. For example, there is a class I have written, container metadata service, which I will explain soon. It's our custom thing, but this REST template is given by Spring itself, right? Spring framework.web.client.rest template to associate to actually, for example, the movie resource has the reference to other class. All you have to do is just add a annotation auto wired. That's it. So now this class knows the REST template. Now once you know the REST template, you can call any REST API. Here we are calling a external REST API. api.themoviedb.org. Okay, and you have to have your API key and movie summary. So if you really want to make this work, you have to go to this URL and register, and you will go to your app key, and you have to put that app key here. Okay, and that is going to give you for a given movie ID the details in the movie summary. So we are not hard coding all those descriptions. Today we got those descriptions. Tomorrow if they change it, we are going to get the start track and short track description. If the source changes, we automatically get the source of truth, right? So this is basically, that is why we kept it as a separate service, microservice, because functionally it belongs separate. It's owned by a this information is owned by separate place. In this case, it is owned by a separate API itself, right? So that's why we have a thing. So now, so we saw those two, and while showing this, I want to give you guys an understanding that if you go and look at the Maven dependencies here, wow. Remember in those good old days, you have to go and add all the jar files within the pom.xml the way you want, right? Still, that is not stopped. You can go and do that way. But now, when you say starter, when you say Spring Web Starter or a JPA starter, right? It knows there are so many chunks of jar files usually people use, and whenever they use, they try to have a REST call. So that's why it gives you the Jackson based jar files, and it puts the Tomcat things by default. Since we put the JPA, it puts the Hibernate things, right? So that is where the opinionated side of the Spring comes into play. And think about it, if you have to do this manually and see why something is not working, the class path issues and so on, now this is trying to prevent it because the automation, you get most of it through the Spring Boot starter thing, right? Okay, so far so good. Now let's go to the third service. The third service is the catalog service. Okay, what is a catalog service? As usual, there will be three classes. It's going to be an application class which will have the Spring application.run method, right? And all we'll be doing is just say right click and run application. Okay, so this is going to, as if it's running a Pojo test, it is just running, but it is actually deploying into the Tomcat server, but on the embedded side, so you don't have to stop it on your side, and you don't have to deploy it and see those mundane jobs are all removed. Okay, let's go and see the third thing. So okay, so now this is 8081 catalog now. Okay, so wow. So now what this is doing is this is a composite service which gives you both the rating as well as movie information put together. Okay, so the name of the movie is blah blah blah, and the rating is 3. So previously in the previous service you got 100 movie ID rating 3. Now who cares about movie ID? People just want to know the name lock, and the rating is 3, right? So the name start track and the rating is, and start track description rating is 4. So you get holistically both the movie information along with the rating information, correct? Functionally, we know what we got, what we want. Let's see how things are done for this. As usual, there will be a catalog resource, and it is a REST controller, and it has the request mapping, right? Okay, so if you see here, get catalog, it is taking the user ID, and what it does is it is calling the user rating service first. It gets the user rating details. Then this is using the streaming API 8.0 JDK 8.0 thing, right? And once you get the collection, it's trying to map it, right? So what this is doing is this is calling the REST template movie host movies and movie ID and movie class, right? And once you get the movie from here, the catalog item is a composition of movie and rating. See, first we are getting the rating here, then we are getting the movie here, and then we are composing both together and returning back here as the collection. Okay. So this is a classic microservices composing, and in nowadays people doesn't want to, if they don't want the synchronous composition, they could go for an asynchronous composition with the event based architecture like course and so on. But if you understand the basic synchronous way of composing the microservices is a crucial thing, and we can make it work and see it realize all the way up, and then we can, once you know how things are working, you can make it better, right? So far so good. So we have seen all the three microservices, right? And I just want to touch base with one more information. There is going to be if you go to a pom.xml file, for example, pom.xml file, right? There is a Spring Boot Docker file Maven plugin, right? So you guys see this Docker Spring Boot Maven plugin. So this is a beauty of creating a Docker image directly from the Spring Boot through the Maven file itself, right? So let me explain what is a Docker very briefly. A Docker is nothing but a container based deployment. So basically, previously, whenever you create anything, it is will be run on a JVM, but you have to have all the dependent class paths along with it, and it's your responsibility. Now, given application, for example, movie rating, for movie rating, whatever the dependent things, whatever it required, it's all packaged together, right? And all you have to do is just go to the URL and run. It is going to run. You don't have to worry about setting up the class path. Does it have everything on the runtime? And this brings beauty for the cloud native application. If you can able to run the Docker on your laptop, you can run the laptop Docker on any cloud native cloud providers also. So in the subsequent presentations, we are going to talk about more on the Docker, creating the Docker, deploying the Docker image in a container, in a AWS ECS container, and whatever you are trying to test here, we are going to test it there. Okay. And before I finish, one more small thing, because I don't want to get into Docker and other things right now, but one thing what I want to get into is um, there is something called @value tag. So let me just show you. We are using @value tag in movie catalog, for example. If you see a resource here, right? If you see here, there is a string called rating host and there's a string called movie host, right? It's basically nothing but the URL, correct? And this URL, um, for example, I don't want hot code when it comes to compose service. For example, catalog is a compose service, and the URLs of the rating service and movie service should be configured using some environment variable. That's what this environment variable is for, right? This is what it is, right? What this is telling you is if this environment value is null, that means use this. In the local environment, the local run, I don't set this environment. That is why it is trying to run these two and we got the value back. But when we try to deploy it into the AWS ECS container, we are going to define what is the environment URL going to be so that we don't have to change the code. The code is going to work on the local side as well as the same code without touching is going to work on the cloud as well. So that is the beauty of it. So hope you guys understood. In summary, we saw what is a microservices, functionally why we need to split the microservices, what do you gain by going for the microservices, right? And then we are having an example. It's a movie catalog, which is a compose service, which is calling the movie rating and movie info. I'm going to put all this in a GitHub repository. I'm going to share it at the end of our presentation. Um, Hope you guys got the first get. We will see soon. Okay. Thank you very much, and I'll start coming out with the next presentation soon.